Good morning, everybody. Today we will discuss the next topic in stereochemistry, that is the conformations of ethane. So we know that the ethane, the molecular formula is CH3CH3, and the ethane can be represented in Sohor's and Newman projection formula. So first one is the Newman representation of the molecule ethane, and the bottom of the slide I have shown the Sohor's representation of the ethane molecule. We have already discussed that the stereoisomers is the isomers which having the same molecular formula but they are differ in their spatial arrangement. So these two are the important conformation of the ethane. We know that there are infinite number of the CC sigma bond rotation possible in ethane. That means infinite number of the conformation are possible, stereoisomers or conformers possible in ethane. But we are mainly focusing the two important conformation of the ethane, that is the staggered and eclipsed conformation. Now, in the staggered conformation, staggered conformation is the stablest conformation of the ethane, in which the hydrogen atoms are far distance. The hydrogen atoms are maximum distance apart, and the electron cloud of the CH bond are as far apart as possible. And here there is a least torsion strain. I will explain the torsion strain little bit later. And we can see that here the minimum repulsion is possible because the hydrogen atoms are maximum distance apart, and the staggered conformation has very low energy. That's why the staggered conformation are more stable. Whereas in the eclipsed conformation, hydrogen atoms are very close to each other as possible, since the hydrogen atom are just behind the other, and the electron cloud of the CH bond are as close as possible, and it acquire the maximum torsion strain and maximum repulsive force and maximum energy. That's why the eclipsed conformation is unstable. See here in the Sohor's representation, in the Newman representation, we can see that in the staggered conformation, the hydrogen bonds are maximum distance apart, whereas in the eclipsed conformation, the hydrogen atom is just behind the other. Now, we are moving into the potential energy level diagram in the case of the staggered conformation. Here we can see that we are just starting from the eclipsed conformation. That means the bond angle is 0 and the hydrogen atom is just behind the other. See the red hydrogen is just behind the another red hydrogen, and if you are rotating the 60 degree, you can see that the angle of rotation in the x-axis and the energy in the y-axis. If you are rotating the 60 degree, we will get a staggered conformation. Conformation have least energy, so that's why it touches the x-axis. Again, if you are rotating the 60 degree, we will get the eclipsed conformation. See the position of the red hydrogen, which are 120 degree apart, and since it is an eclipsed conformation, it have the maximum energy. Again, by rotating, we will get the staggered and so on. So this is the potential energy level diagram. And here in the potential energy diagram, it is very clear that the eclipsed conformation have the maximum energy and the staggered conformation have the least energy. Why the staggered conformation are least stable than that of staggered? That is an important question. In staggered conformation, it is devoid of the torsion strain and repulsive force is minimum, since the hydrogens are maximum distance apart. So that's why staggered conformation is having least energy. Now we are moving into the next topic, that is the structure of the cyclohexane. We know that the molecular formula of the cyclohexane is C6H12, and it exists in the two conformation, that is the chair conformation and board conformation. The two more conformation is also possible in the cyclohexane, that is the half chair and twisted board. And first of all, we will discuss the chair conformation and board form. That is the most important conformation of the cyclohexane. So see here we are expecting the bond angle in cyclohexane is 120 since it is a 6-member ring. But actual bond angle is 109 28 minute. This is because the cyclohexane acquire the sp3 hybridization, approximately sp3 hybridization and every carbon atom, and all the carbon atom does not exist in a single plane. That's why the bond angle is 109 degree 28 minute, and the structure since they are not planar, it having a backward ring structure. The first two one, that is chair form and board form, are the most important conformation of the cyclohexane. See in the chair form we can see that the end position, that means the carbon atom in the end are one is in the up and the other one is the down. So these two carbon atom are the maximum distance apart, and the remaining 4 carbon atom exist in the one plane. Whereas in the board form, the 2 hydrogen atom are in the upward direction, so it experiences maximum repulsion. Now we are moving into 3 important terms, that is angular strain, steric strain and torsion strain. First we will discuss the angular strain. See here I have shown the 3 sigma bond AC, CC and CB. These are the 3 sigma bond, and these 3 sigma bond exist in a 2 different plane. I have shown the 2 different plane by a ash colored boundary. So ACC exists in one plane, ACC plane, and the CCB bonds exist in another plane, that is CCB plane. So the angle between these two planes are known as the dihedral angle. So see here in this this is the dihedral angle. So for the first case, that is in the eclipsed one, the dihedral angle is 0 degree. Whereas in the staggered conformation, we can see that the bond exists in A, C, C, B, and A and B are on the different direction, and I have shown in the Newman projection formula. So the dihedral angle is 180. That means the maximum distance apart. So as the dihedral angle decreases, the repulsion is also increases. That means it occurs an angular strain. See, these are the different conformation of the ethane molecule. First is the eclipsed conformation. See here, in the eclipsed conformation, 2 red hydrogen are the just behind. So the bond angle is 0 degree. Again, if you are rotating, we will get another conformation. The name of that staggered conformation is gauge form. Here we have rotated 60 degree. So again, if you are rotating 120 degree, we will get eclipsed conformation. Again rotating, we will get next staggered conformation. The bond angle is 180. So the most important conformation of the ethane I have shown in the rounded conformation, that is 0 degree eclipsed and 180 degree staggered conformation. So in the eclipsed conformation, the dihedral angle is 0 degree. That means it acquires the maximum angular strain. Whereas in the staggered conformation, the bond angle is 180 degree. That means it acquires the least repulsive force. Now we are moving into the next heading, that is torsion strain. Torsion strain means, see in this example, one of the hydrogen in the ethane molecule is replaced by the chlorine, and the 2 chlorine atom is just behind the other. That means the electron cloud in the chlorine atom, one of the chlorine atom is very much closer to the electron cloud of the next chlorine atom. So it acquires a repulsion, and this repulsion is also exists in the sigma bond electron also, because the sigma bond is formed between the CCl, CC and Cl bond. So there is an repulsive force is exist in the sigma bond itself. So this type of the strain is known as the torsion strain. And here we know that the atoms, chlorine atoms, are very close together in the space, and the electron cloud repel each other. This type of the strain is known as torsion strain. Next we will discuss the steric strain. As the name indicate, the steric strain means it is the strain which arises due to the presence of the bulky group. Here as we compared the hydrogen CH3, that is the methyl group is steric one, bulky group. So it acquire a steric repulsion. That means bulkiness of the group. So this one methyl group is just behind the other, and there exists an electronic cloud, there exists an repulsion due to the bulkiness of the methyl group. That is known as the steric strain. So today we will discuss the important conformation of the ethane, conformation of the cyclohexane, then steric strain, angular strain and torsional strain. I hope that you understood the concept. Thank you.